is not working this. I have to stay close to here. So, we have been performing this. I have been performing these studies with David and Danielle from Rio, and so you know all this. Yes, I will not include I will show you only the results. So everything here you know already from the initial talk about the upgrade and future experiments. Well, here we are mainly interested in the two-photon physics, in the effective photon approximation. Okay, so in different channels, we have we intend to perform ZZ in the close future, but nowadays we are focusing on Higgs to BB bar and to WW into 4 jets. Okay, so and also possibly constrain the anomalous quarter gauge couplings in these both scenarios. Okay, well, okay, so one of the we have been I have been working in these channels and in this FCC scenario since 2015, when I arrived at CERN with David. But that time, the Monte Carlos, so the event generators were not available, or not the EPR, the effective photon approximation, was not properly implemented for electron-positron beams. Okay, then so we have contacted many MAD-graph generators authors, many Monte Carlo generators authors as MAD-graph, PITA, and nowadays they are improving a lot, mainly PITA-8, and now we have the new one, Super-Chic. And so they improved a lot the Monte Carlo generators, and we could reprocess our signal and reaching good results. Okay, so in the first we have used Super-Chic and PITA-8. Okay, in the case of Super-Chic, we have both processes. Okay, in fact Lucien has changed, and we have the WDK suppressed to generate the 4 jets channel, because the process was implemented only in the full leptonic channel, and so these both channels can be generated. The events could be generated in Super-Chic without any problem. We have constrained the virtuality of the photon to for the quasi-real photon because of PITA-8 comparison. In PITA-8 only quasi-real photons are considered, so we could not increase this range here. And so Ilka has implemented, he's working on it as well, only for Higgs, Higgs to BB bar, and also for the continuum backgrounds. Okay, we have used MAD-graph as well for the proton lead and lead beams. I did some gymnastic to have an estimation of the anomalous quarter gauge coupling exclusion limits using MAD-graph, because it's the only Monte Carlo generator available to implement new models. Yes, and PITA and Super-Chic is not straightforward. And so in this analysis, so we have been performing different ways of tagging or to estimate the influence of the detectors, the FCC detector. And now we have used the beamline tagging. So we have adopted the lepton scattering angle less than 1 degree to make our analysis for EDS. If you want, you can take a look in Photon 15. Was the first in Photon 15. It was the first time we presented this some results on these channels. After that, in other workshops of FCC as well at CERN, and the last one was in June in the EDS. Okay, well, okay. So you will see here. So we have used the super-Higgs and so for the Higgs to BB bar in the lepton mode of FCC. We used the super-Higgs and Pitya, so the similar results, same cross-section, same all compatible. We have used also a B-tag reconstruction and mistagging to know to make a prediction of the BB bar detection in the detector, yes, in the FCC. And so as you see here, so the background, the dominant background should be killed with the lepton positron, with the electron positron tag. And so these are the factors we have applied for the mistagging of B and C, of C and the light quarks, and the efficiency of the reconstruction of the B jet. Okay, so all based. There is a paper of David from 2009 where he has all these factors. He has adopted all these factors, so it can be checked there. So you see here the distributions before for 240 GeV center of mass energy. You see that so the background is very prominent. Yes, it's huge, and so the counts. Here is so the integrated luminosity, the luminosity per year for each expected for each center of mass energy in the lepton scenario of FCC are here. So we expect 15 attobar inverse per year with 2 interaction points for 160 center of mass. So 3.5 attobar inverse for 240 and 350 for 1 attobar inverse for 350. Okay, so you see here what we expect without cuts, yeah, without any cut, only assuming these factors, and so. Okay. Then the cuts we have applied. We need to tag the electron positron to remove the background. Okay, and then we have considered 3 scenarios. In these both scenarios, the central tagging and forward tagging, we could not get any event remained in this photon virtuality. Okay, assuming the quasi-real photon, but we could get results using the beamline tagging. Okay, removing 25% and very low of the signal and backgrounds. So beyond that, to remove reduced background, we included the PT cut. Well, in this region, okay, removing a lot the background, killing 66% of the signal, and to restrict even more our region, as we are interested in the resonance, in the Higgs resonance. Then we have estimated a resolution of 7 GeV. If so, applying this invariant mass cut window here, and this would remove mostly the background from our signal. And after all these cuts, we could get an estimation. So you see here the distributions, the same. So before you see it without cuts, now with after cuts, and then you see with this initial cuts that we can reach very good significance in 1 year at FCC in all modes, in all center of mass energy modes for the lepton consideration. So I didn't compare with LHC, but I don't know if CTPPS has for the Higgs BB bar. No, for do they have a project? For the international. LHC. Sorry, sorry, LHC. Okay, good. No, I didn't make any comparison with ILC. Do you remember which energy, the parameters of the beam? Okay, yes, because here we are assuming. So do you know the luminosity? I don't know, because here there is a quite well estimation of the luminosity, and also including these 2 interaction points. So it's more specific, yeah. So otherwise it's hard to estimate. Only based on the luminosity. It's well, I can check. I don't have information. Yes, sure. Yeah, no, sure. Even with the Chinese. With the Chinese project, yeah? Okay. And so we did. So these are the results for the FCC in electron positron mode, and then we did for the heavy ions. Okay, so proton, lead, and in this case, so we did this. So there is no tagging, yes, and well, here we have used. So that is we changed it. We used super chic, okay, and MADGRAPH, because from heavy ions we have a photon flux very well implemented, and then we have included this photon flux under the supervision of Lucien in MADGRAPH and in super chic, okay, and both were adapted with photon flux. Yes. I have forgotten to say that before that all samples were properly showered and hadronized with P8, and also the reconstruction of jets were performed using fast jet 3. Okay, just to. Yes, sure. You have yeah. It can be. You have all that. Okay. I don't know if, because Daniel was taking a look, I don't know if he has used, I guess he has tried to use FPMC, but something was not working well. I don't know. I have to check with Daniel. Yes, so I will check with him because we have. I remembered that we were talking about the FPMC, and we could not use it because something that I don't remember now. But I can check with him. Well, to constrain, okay, our phase, to restrict our phase space, you know? We have adopted the invariant mass range. We have PT, yes, and also the eta region. Applied the reconstruction and mistagging factors as well. Okay, so for the signal, we've got these results for the cross section with these counts, assuming. So here you see the luminosity for, so the lead mode would run at 39 TeV, assuming this 110 nanobar inverse nanobar per year. Then we have these counts per year. Okay. Now you see that the signal is hidden behind the background. Oh. Okay, and you see here you have plotted the central system. Okay, and Z, so the longitudinal momentum here. So for you to have an idea about the emission, very high longitudinal momentum, yes, of the lead. So, but the work based on this, on the paper, David's paper, and okay. So the analysis cuts. So beyond that basic restricting the phase space, we have applied this the analysis and efficiencies. So in the irreducible background, used the PT of the jet, removing mainly the background, killing 35% of the signal. The acoplanarity also a good cut to remove the background. Okay, you see the comparison, or quite the same PT, and to quite kill totally the background, so removing 88%. We have assumed the resolution of BB bar 3 GV. And so applying, yes, and applying, so the restricting a lot the invariant mass of the Higgs, yeah, of the BB bar system, yeah. Then we could remove a lot the background. And after these cuts, we can see better our signal, mainly on the central mass system. And also here there is no change at all, quite no change. And so in the end, we could get 3 sigma, so the evidence in 7 months of running the FCC, the lead for this channel. And in 1.5 years, 1 year and a half, 5 months, we could get a discovery. So it's at least assuming this analysis. So in the case, so the procedures for lead, for proton lead, were the same. You can see the details in in the backup slides. I can show you, but we applied quite the same cuts, yes. And here we would last. So it would take longer to get an evidence at least. Okay, so 2 years to get evidence. Okay. Now, okay, so now the WW24 jets. The theoretical setup, we have used it again, so the super chic picture to modernize. So the backgrounds. For super chic and picture, we could not process backgrounds because it's not implemented. So only in picture 8, only the Higgs. So only Higgs it's implemented, and the super chic also gamma to 4 jet is not implemented. Okay. And then, but it's implemented very well implemented in picture 6. So I have been using picture 6 since the start of this work back in 2015. And for backgrounds in picture 6, using also the equivalent flux, etc. Also initial state radiation, final state radiation, everything turned on as I did in picture 8 for the previous analysis. So jet reconstruction using the fast jet tree with this with the KT algorithm. Also try to put some limits in the anomalous quarter gauge couplings. And you see here that for lepton mode, so we have interesting a hidden signal, okay. And in the case, here it's very the backgrounds would be the electron positron to 4 jets with Z glues in the middle, with the Z and photons in the middle. So it would be killed. While so with this tag, with the beam tagging, okay. So the gamma to 4 jets, it's also huge compared with the signal, yeah. So you see 10 times, 9 times bigger for both energies. So before cuts and after cuts, so the cuts we have applied in PT in our pseudo rapidity, also the distance between jets, invariant mass, and using again so the beamline tagging. So after these cuts, you see the difference. You see the improvement of the signal over the background, and we should expect very early for the FCC-ee run a discovery, an observation of this signal in both center of mass energies. Okay, so it should be very early in very low luminosity. We could get very good results. Okay. For we performed also for lead. So the same, but assuming the lead flux, so the same integrated luminosity from the Higgs for sure, yeah. And also using MATGRAPH here. So here you use MATGRAPH, okay, and practically the same. So the cuts in the invariant mass, more relaxed, yes, and to restrict the phase space, yeah. This is the nuclear mass because so it is informed here because the photon flux was how can I say, readapted to assume a structure for the proton. So it's mimicking the nuclear mass here, And so we could get, so you see the background is incredibly huge, yeah, for the gamma-gamma to 4 jets. So after some cuts to enhance the signal, so PT greater than 30, and so we have restricted eta region, we have restricted the invariant mass, so we could kill a lot the background, you see, in comparison with only basic cuts. So to remove this continuum for jets, we applied the PT again. Okay, selecting. So it's summing up here. Yes, and so in the end, we could improve this significance with an evidence of the signal in 1 day running. Yes, and so soon after that, so with very few days, we could observe this signal in the lead run. Okay. The same we did. So let me see if I didn't stop. Okay. Then to estimate the anomalous quarter gauge couplings, we could not make huge, very precise calculations because of the limitation of the Monte Carlo generators. Then what I did, well, I generated samples with MATGRAPH, okay, and then I took the difference from, because in standard model we have a difference in SuperChik and MATGRAPH 5 for the photon flux, okay? So the implementation are a little bit different. So we have a difference in cross-section. Then I took a factor, a standard model cross-section factor. It's so in SuperChik is more or less 0.47 times MATGRAPH 1. And then I generated samples in MATGRAPH for the anomalous quarter gauge couplings and used this factor to have an estimation of cross-section in SuperChik. Okay, so more a little just to get an idea about the improvement in the dimension 6, couplings, anomalous couplings. Then we see that in the case of the CMS, this is the 8 TV in CMS. It's not assuming the CT-PPS improvement, yes, because I don't remember this. Do you remember the estimation of the 2 orders of magnitude? Okay. And so for the case, so comparing with the 8 TV analysis, this is the most stringent limits of gamma-gamma to WW so far we did in the forward physics analysis. So we could decrease, so we could constrain even more the anomalous quarter gauge couplings of the dimension 6 operators, as you can see here. Okay, even for both electron positron and lead modes. So it's very promising for sure. It's needed. So we are not taking care of the interference terms. So all computation of anomalous, yes, the full diagrams, set of diagrams, we are not assuming here, but in a very very initial estimation, we could get good results constraining the exclusion limit even more. Okay, and well, these are the results. In the case you want to take a look in the backup. Okay, so this is the contribution of the resolved photon to Higgs production. So we did the calculation, and it's indeed not important. It can be disconsidered. We had here. Okay, this is the slide of proton lead mode without cuts. Okay, so you see here only with the restriction of the phase space, and and the analysis cut we have applied. So it's basically the studies are basically these ones. So we expect very good scenario, as you see, for these both channels. We didn't perform so far the ZZ channel, and so we aim to do that quite fast, because we need, in principle, we need the implementation in super-chic. So we need the improvement in the Monte Carlo to make this computation yet. Okay, so these are the analysis. So one question that has arisen in the ADS was about the how can I say, radiation corrections for this signal. So it's implemented. There is no calculation next leading order. So I don't know if you know some implementation of it. No. Well, these are the results, and if you want to, what the main the main problem we had during these 2 years was the Monte Carlo generator, mainly for the lepton beam. The lepton beam is only now super-chic is available, but with a restriction of channels. So we have Higgs and we have the WW, other productions too. But only in the hadron. Do you have a FMC has dimension 8 as well? Okay. Yes. Okay. The dimension 8. Okay. Yes, I will ask Daniel if he could. Okay. Yes. I imagine. Yes. Daniel is working with Murilo in that. Yes. I guess he's working with Murilo as well. So this is my humble contribution to FCC. Ah. No, because it would be tested. So do you mean what would so? Do you mean we could only make studies of in the lepton mode, not in the lead? I didn't understand. Maybe I didn't.
Are you winning something by this measurement?
Yeah, the same point. I mean, what do you gain looking at this process, gamma gamma to Higgs in the V bar, also in the heavy ion mode? Do you expect that something different might happen? Because it's, normally it should be
No, it should.
cleaner in the FCC
No, for sure, it's easier. It's much easier, for sure. But if you think about uh, the confirmation of results, and I don't know if we would gain something running in different scenarios, but we are going to start. FCC will start with the electron positron. Yes, so. From my CMS experience, it's very common that you have results in one lepton in one kind of scenario, in one beam scenario, and then this result would be tested in lead also. Well, as you see, we could get good results in lead as well. For sure, we need to take into account the scenario of the detector. Yes, because so maybe with more developments in the detector project, we can assuming this other the pile-up things like that. Yeah, maybe it's not possible if we take into account other variables,
But you see this process with quite some statistics, the lepton collider
it will be much better. Yes, our study was so since the beginning has focused on the lepton mode. Okay, so I am doing this analysis also mainly only in the lepton mode. Okay. Then, so after the development of hadron-hadron projects, yes, in the FCC, with Michelangelo Mangano,